What's up, notJust developers? In this tutorial, we're gonna implement FlatList animations in React Native using Reanimated 2 library, and this tutorial was actually inspired by the iOS notifications. If you want to follow along, make sure to download the starter project and the step-by-step guide following the link in the description below. And without further ado, let's jump into it. Let's have a look at what specifically we will want to animate there. We're gonna work based on the lock screen of iOS 16, and here we have this beautiful flat list here. What we want to do is to animate the way our items are moving down, because at the moment it's quite boring, like they are plain, like moving up and down. What we want to do is to have like something more similar to this, where the items in the flat list, they seem to appear from the behind instead of coming from the bottom of a screen. This animation is inspired by actually FlatList, by actual list of notifications from iOS 16, and we're gonna try to replicate it with React Native and Reanimated. Let's have a look at what actually happens and what we will have to do here. So, as you can see, the items, we're playing with their, first of all, with their size, because you see that the last item here is a bit smaller than the rest of items that we see on the screen, and it slowly grows until it reaches its position. And when it reaches its position, now the animation for the item is finished, and we expect the next one to come into the view. Besides the scale, we also play with the opacity. As you can see, the more I scroll down, the least I can see the item in the back. And when the animation finishes, I cannot see that item at all. The same way when I scroll up, the opacity of the item increases until it reaches 1. And the last step is to simulate this feeling of items coming from the back instead of from the bottom. And to do that, we're gonna play with the translation of the last item, and we're gonna move it with the same speed as the scroll speed in order for the item to slowly come back and into the view. I think it will make more sense when we actually implement it, and we're gonna do it step by step, so don't worry about that. Besides these cool animations of things appearing and moving out of a screen, we're gonna also animate the footer. So as you can see, when the list is all the way up, the footer is displayed here. And when we start scrolling a bit, the footer disappears to make more room for our flat list. And yeah, like the same, like when these things happen, everything is also smooth. We are not jumping to like a bigger size, but we are slowly animating up and down. The same goes when we scroll up, our footer appears slowly and it leaves a bit less space for our flat list. And lastly, in this video, we're gonna learn how to dismiss a flat list and move all the items to below the screen in order not to see them and to have a clear screen like this. And whenever we swipe up, we see them back on the screen. So I'm pretty excited about that. And with that being said, let's get started. Alright, so the first task is this get started with Reanimated, and we're gonna start by installing Reanimated in our Expo project. You can have a look at the documentations of Reanimated here, and actually I'm gonna open it up because we're gonna look through the documentation from time to time, and then we have an installation guide specifically for Expo. So go ahead and open it up, but the only thing that we have to do is to use npx expo install React Native Reanimated. So let's go in our project and start with that. I'm gonna open a terminal and let's do npx expo install React Native Reanimated. Enter. So after it is installed, we see added 5 packages. That's good. The next step is to change a bit the bubble.config file, and what we need is this plugins React Native Reanimated plugin. So let's copy this. Actually, let's copy the whole babel.config if this is a new project, but if you have like made already changes, it's better just to copy the plugins from here. Let's go in our application. We find in the root directory the babel config, and after the presets, we can paste the plugins. Now, after that is done, we should restart our development server and we should start it again and also clear the cache. So let's go ahead and stop our development server using Ctrl+C or Command+C, and then we're gonna do npm start, then -- space -- clear. This will send the clear flag to our expo, and it will make sure to clear the cache in order to include the newly added Reanimated plugin. Okay, so let's press I to open it on iOS. If everything is running without any problems, then good job. That's it. We can move on to the next step because our Reanimated is installed and correctly set up with the plugin. So in the FlatList animations, I don't have a lot of snippets, but we're gonna do it step by step together. So the first thing is, let's work on the hiding and showing the footer whenever we scroll the list. Whenever we scroll the list, we need to hide and show the footer. So how we're gonna do that? As you can see here, the logic behind when the footer should be visible and when the footer is not visible depends on how much did we scroll in the list. Because if we didn't scroll at all and we are all the way up, the scroll position is 0, then the footer should be visible. When we start scrolling and we pass like a very small threshold of like, I don't know, 5 pixels, then our footer should be invisible and we should smoothly go through the items. So, as I said, we need to work with the scroll position. Let's open our notification list, and here in the FlatList we can provide an onScroll event, and we can provide a function that will be called every time the FlatList scrolls. That function we're going to define using a helper hook from Animated. So let's import Animated and React Native Reanimated. And the hook that we're interested in is the use animated scroll handler. So using this hook, we can define our handler that will handle the scroll events. Handler equal use animated scroll handler. And here we need to provide an object. An object that can receive a couple of properties, and all of these properties are the events that can happen while we are scrolling. One of these events is, for example, on scroll. Let's do event. This on scroll event, I can console log. The problem is that it has a lot of things, so I'm gonna only console log one property of this event, and that property is called content offset .y. Content offset is the value representing how much our content has been scrolled, basically the scroll position in our list. So now if I send the handler to the onScroll event, if I open up our terminal to see the logs, and if I start scrolling, type error, this props on scroll is not a function. Oh yeah, because the FlatList should be an animated FlatList, animated.flatlist. Okay, now if I'm gonna scroll, I already see how many pixels we scrolled to the bottom. So as you can see, if I scroll more and more, it displays the amount of scroll that we did. If I go back up, we get to the 0. Interesting part is that if we pull down, we can get to the minus content offset, because actually that's how it happens. We move in a different direction. So now the idea is that based on this scroll event, let's grab this into a variable like this. I don't need to console log it anymore. And we're gonna say if y is less than 10 pixels, that means that we're on the top of the screen. So here we should have the footer opened. However, if y is more than 10 pixels, we should close the footer. But what I want to explain here with the onScroll event is this onScroll event handler will be called as many times as possible whenever we scroll through the feed. But the thing is that we don't need this onScroll event to be run more than 60 times per second in order to have like a 60 FPS animations. Anything more than 60 times per second calling this handler will not improve anything, because most of the phones have a 60 FPS refresh rate. So in order to limit how many times this on-scroll event is being called per second, the maximum time, we can provide their throttle, scroll event throttle, and scroll event throttle will receive 1000 divided by 60, because we want 60 frames every second. So that's actually 16, if I'm not mistaken. And just by doing that, we make sure to throttle and not unnecessarily call this handler on our FlatList. With that being said, we can move on to the application, because here we are working with the footer, and we need to think about how we should drive animation for the footer to make it disappear and to make it leave more room for our FlatList. As I said, we don't want this to be jumpy, so we need a value that will drive this animation in a smooth way. That value, we're gonna use the use shared value from React Native Reanimated. And this use shared value allows us to define a value that will be on the UI thread, and this is going to be much more performant for driving animations. So we're going to define a value, footer visibility, use shared value of 1, footer visibility. And the footer visibility will be a value that goes from 0 to 1. And based on this footer visibility, we're gonna both work with opacity and also work with moving it down to give space for the FlatList. So that's why we have one single value that is going to drive two separate animations. And that's why we have it from 0 to 1, because later on we can use some math multiplication to get the value that we actually want, mapping from one range to another. Alright, so with this footer visibility, I can go ahead and define a style for our footer. So animated footer style equal use animated style, and here will be the object for our animated style. So as I said, what do we want to animate? We want to first of all animate the opacity. So the opacity, because opacity is also a value from 0 to 1, we can use directly the footer visibility dot value. So when footer visibility is 1, our opacity is 1 and the item is fully visible on the screen. And when it is 0, our item will not be visible on the screen. So let's see if it works. Something is not working there. Use shared value. Where is it coming from? Is it coming from here? Use animated style, opacity. Oh, use animated style. In case we are working with shared values, the use animated style should be a function that returns an object, not directly an object like this. And now it's gonna work, but we need to provide this animated footer style to our footer component. Where is it? Here. Animated view. It is already an animated view, so we simply have to add the second style here, animated footer style. At the moment we don't see anything changing, but based on the value of this footer visibility, our footer will appear or disappear. So if I put here 0.5 or 0.1, we will barely see it. Yes, we barely see it. But instead of doing it manually here, we need to drive this animation when we start moving down. So we need this footer visibility property. We need to have access to it from our notification list. So let's send the footer visibility there through props. And in the notification list, we're gonna receive the footer visibility here. And when here we should have a footer open. That means that footer visibility dot value will be equal to 1. And here the footer visibility dot value will be equal to 0 because we need to close it. So let's see if it will work. It's not going to be animated yet, but let's see if at least the logic is there. So I scroll down and the footer disappears. I scroll back up, the footer appears. So that means that we successfully mapped an animation to the scroll event of our FlatList. Now the last step is to properly animate it, because we don't want to jump from visible to not visible. We want it to smoothly appear. So instead of setting the footer visibility right away to 1, we can use the with timing to have a slow progression to the visibility and also slow fade out when it disappears. Let's import this with timing from Reanimated with timing. And now, as you can see, it slowly disappears and slowly appears. In order to see it better, we can increase the duration of this to 1 second, and then we're gonna be able to see it properly. Duration 1000. Slowly disappearing, slowly appearing. Okay, now that you see it, I'm gonna remove this duration because I think it looks well with the default duration of 300 milliseconds. Perfect. The next step is, besides working with opacity, when it's not visible, we need to give this available space to our FlatList. To give this to the FlatList, we can work with negative margins. So for example, if I'm gonna say margin top is -10, then it moves, the elements on the top will have a bit more space. And if I'm gonna do margin top 50, then as you can see, we almost have a space. We remember that our footer has the height of 75 and also margin bottom 10, so probably 85 minus 85. Let's double check if that's actually true. Yes, if I put 75, we see there is still a little bit of space available there. And if I put 85, it's right where it should be. The problem right now that when it appears, we do not give back this space to the footer, and the footer is displayed on top of the list. So this value should be 0 when footer is visible, and it should be -85 when footer is invisible. So for that, we can use an interpolate function to map from one range to another. And as I said, the one range that we're mapping to with interpolate, the first one is the value that we want to use to drive this interpolation. The value will be the footer visibility.value. Then we have the input range, and then we have output range. The input range is what is the range of this footer visibility. It's from 0 to 1, as we said, so 0 to 1. Now the output range is what are the values that we want to map to. So when footer visibility is 0, our margin top should be -85. Because we need to give that space to the FlatList. But when the footer visibility is 1, we want margin top to be 0. And just like that, if I'm gonna scroll down, we see how it smoothly gives back the space. And it's driven by the same animation, footer visibility. So if in notification here, we're gonna go back to the, I'm gonna do Ctrl Z. Because it's driven by the same shared value, both of them will move basically in the same rhythm. You see, it's very slow, and if I go to top, it's very slow, both of them, because it's 3000 here. I'm gonna remove it, and we can see it, how cool and snappy it is at the moment. Boom, boom. Okay. I think we're done with hiding and showing the footer. Now, let's start probably with hide and show, because this might be a bit easier for us. Let me quickly animated footer, like that. Now, the next step would be whenever we scroll down, we want to hide the list. You might think that hiding the list is moving the whole flat list below, and that was the first step that I tried when implementing this animation, because this is the easiest way. We take the whole flat list and we, with some animated style, we move it out of the screen. But in that situation, like, all our items will move with the same speed. So this is not exactly what iOS is doing. Because if we look here, when I close down, all items move with different speeds. I'm not sure if you understand what I'm saying. Most probably it doesn't move the whole flat list, it moves individual items. And as you can see, like they move with different speed to create this effect of appearing. So how we're gonna do that? We're gonna do that by animating each individual flat list item instead of animating the whole flat list at the same time. So we're gonna go in from the notification list to the notification item, and here is where we're gonna start working with animating this item to move out of a screen whenever we scroll all the way up to hide these items. So what will we need? We will need animated from React native Reanimated. We will definitely need animated styles, so use animated style. What else? We will most probably need interpolate. Okay, probably that's everything. All right, so let's go ahead and define the styles or animated styles. Animated style equal use animated style, and here let's define the function that will return our object. So it will simply return an object, and here what will we animate? We will animate the position of every single individual item. So for that we're gonna work with transform. The transform here, let's send an object. We're gonna translate them on Y. So if we translate them like, I don't know, -100, that means that they will all move down. So let's go ahead and give this animated style to the first view, but for that we need to make it an animated view, and the style here. If I do 100, yes, I think it should be positive, yeah. And it slowly should go down like this, all of them. I can do here with timing 1000 and duration 3 seconds just for you to see it. And let's go ahead and do it like that with timing. Oh, here we go. This way they are moving, but at the same time they are moving all with the same speed. Moving with the same speed is not the biggest issue. The biggest issue is that we need to trigger this movement whenever we scroll down and we like take your finger out of the screen, and when that happens we should move all the items down. We are in the notification item, so all the scroll events are happening in the notification list. So let's go ahead here in the notification list, and the same way as we worked with a visibility, like footer visibility value that goes from 0 to 1 gradually, the same way we're gonna have a visibility for our flat list. So list visibility is going to be equal to use shared value, and it's gonna start with 1. It's going to be visible. Now let's go ahead and send this list visibility to all our notification items. So list visibility equal list visibility. We should not forget to import use share value from Reanimated, and in the notification item, let's go ahead and receive here list visibility. Now with this list visibility, I can drive the translation of every item. Because list visibility is a value from 0 to 1, we need to remap it to a value from 0 to 500. So for that, we're going to use an interpolate. We're going to interpolate the list visibility.value. The input range, as I said, is 0 to 1, and the output range. So when list visibility is 0, the translation should be 500 at least. And when list visibility is 1, that means that list is visible. The translation should be 0. Save. Okay, it's there. Now let's change from the notification list item. Let's change this list visibility to 0 and 1, depending on where we scrolled the list. Because if I do 0 right now, nothing changes there. But if I refresh, it's there. Yes, it's all the way down. So where we're gonna do all of these checks? We're gonna do these checks also in this use animated scroll handler, but instead of doing them in the on scroll event, we're gonna do them in other events called on begin drag. This is going to be an event that is going to be triggered when we start dragging, but to hide it, we need the on end drag to see where we ended. So this event also has like this content offset Y. So when we end the drag motion, if the event content offset is less than 0, that means that we are dragging in the opposite direction. Then what we want to do is we want to change the visibility. List visibility dot value is going to be equal to, probably with timing, to 0. We want the list to be hidden because we let the finger outside like when it is 0. And it actually works, but it doesn't come back. We should bring it back when we begin scrolling. So when we begin scrolling, we should probably do visibility to 1. But I'm gonna do that only if a list is invisible. So only if list visibility.value is equal to 0 or is less than 1. If it's not visible, then make sure that it is visible. So now if I'm gonna scroll down, it's gonna disappear from the screen. If I scroll up, it's gonna appear on the screen right away, in a very smooth way. Besides the with timing, there are other ways of running animations. And there is this with spring function that simulates a spring animation. So let's change the list visibility to work based on the spring. And this way you're gonna see, I don't know if you'll enjoy it, but it will move a bit differently. We can see there on the top, like it moves up and then slowly comes into the place, just like that. Okay, but as I said, we are really not that interested in having all the items move with the same speed, because at the moment they all kind of move with the same speed, right? What we're interested in, the items on the top should move with a higher speed than the items on the bottom, because they have a longer distance to travel. We're gonna draw because it's gonna be easier for me to explain. So we have there our list, and let me actually draw it. So here we have our phone and we have our items. I'm not gonna be too perfectionist, I'm gonna do it like this. And actually it goes all the way below the screen like this. Okay, so every item, what we are doing right now is that every item will move 500 pixels below. So the first item will move 500 pixels below, so it will go here. The second one will move 500 pixels below and it will move here. The third one again, and so on. Every single item will move the same amount of distance on the screen. And when an item moves the same amount of distance in the same amount of time, that means that they will move with the same speed. So that's why we see that they all are moving with the same speed. In order to have that feeling that the top item moves faster, we need to increase the speed of the first item. So to do that, we should either decrease the time it takes to run the animation, or we should increase the distance that the element should travel. So how we're gonna do that? We're gonna, instead of moving all of them 500 pixels below, we're gonna define a barrier, like a target position somewhere here, and we're gonna try to move all the items to that position. So what does that mean? It means that this item will come here, this item will come here, all the way until the last item will come here. And even like the items below will come here. So in this way, for the first item, this one, we increase the distance that it has to travel. So the distance for this item is much more than the distance for this item. So when the distance is higher and the time is the same, it will feel that it moves much faster to do the same amount of job. So with that being said, let's go ahead and instead of moving 500 pixels to the bottom, we're gonna move it to a predefined position. Like the amount of pixels we need to move is different for every single item, and it depends on the position of the item in the list. So that's why we have here the index to know which position is this item displayed at, and based on the notification height we can know at what distance it starts. So what we need to do is we're gonna work with the notification height. Let's save it into a variable, right? So const start position of an element is going to be equal to the notification height multiplied by the index. So for the first element, the start position will be 0 because index is 0. Then the second element, the start position will be equal to 80 because index is 1, and so on. So we need to say that 500 pixels minus start position, because that's the distance between the element and the target position, if the target position is 500. So we said that we want to move the item only the difference between the target position and its start position, basically the distance that it has to travel. So now if I'm gonna move it, as you saw, they kinda stack together. So for that reason, I'm gonna slow down a bit this animation using the width spring to 0. Does it have a duration? No, it probably doesn't have a duration. So I'm gonna move a bit to the width timing just to show you what happens with timing 0, duration 5 seconds. Now, if I'm gonna move down, you see the top items are moving much faster than the bottom items. And this is how we get this effect of items moving at different speeds and they kind of stacking all together. The problem that they are displayed here, they are still visible on the screen, is coming from this value 500. So if we increase this to the target position, if it's 700, then it's gonna be much better. We don't see it anymore. And it comes back up. Already looks good. But instead of hard coding this position 700, it's better to take the dynamic position of the height of this flat list minus the height of the view that renders the items. I wouldn't say that it's the whole flat list because the header also is part of a flat list, so we cannot take the full height of a flat list, only the height of the container displaying the items. So how do we do that? We know the height of the footer, we know the height of the header. That means that we can simply use the screen height and subtract these two values. So to get the screen height in the notification item, we can use the use dimension hook imported from React Native, use window dimensions, and here in the notification item, let's do const height equal use window dimensions. Now, container height is equal to height minus the size of our header. And if you remember, our header has a size of 250 pixels. And the container height is also minus the size of the footer, 85 pixels. So now this container height can go here instead of a hard-coded data to go like right away container height minus start position. And actually we should add a bit more to the container height because this way it will go right there, like right below the container height. The idea is that to decrease a bit more than the container height so that the items do not show up when we jump with a spring. So we can do like, I don't know, 50. Oh no, it's the other way around. It shouldn't be minus, it should be plus. So if I do plus, I still see the spring animation to the bottom. You know what? When disappearing, let's switch to the timing animation. And when appearing, only spring. So now it appears with spring and it goes with timing. Perfect. And it actually doesn't need this plus 50 if it's timing because it's not going to be visible. Unless like in some weird situations. It's too close, like it's just there under the footer. Perfect. So we have some of the things that we need here. We are moving all of them down below. Another thing is to, whenever we are moving them below, we should also resize themselves to shrink and to make it like they moved to the center of the screen. So for that, we're also gonna animate the scale property of our notification item. And for that, like in the transform array, let's add another transform that is going to work with the scale. So the scale will be an interpolation of the list visibility value. So list visibility always go from 0 to 1, and our scale should go from, when the visibility is 0, should go, probably it shouldn't be 0 scale, but 0.8 or 0.7. And when the list is visible, the scale should be 1. Now they all shrink. Duration 2 seconds just for you to see it. So when they go down, they also shrink in size, and you can adjust how much it shrinks like based on this field. So if it's 0.5, like when we reach the bottom, they will be half of their size like this. I think 0.5 actually looks also good. And the last step is to also work with opacity. Opacity is another property besides the transform. So after we close the array for the transform, let's work with the opacity, and the opacity will be, should it be list visibility value because it goes from 0 to 1. So yeah, it kind of works. And when we go down, they also decrease their opacity. So with disappearing the list, I think we are done. Hide and show the notification list. Yeah, notification list disappears. I can remove a duration right now because we are done with the animation, so it should look really smooth and fast, just like that. So our last step in this tutorial is to implement the animation of the last item. So animate the last visible item in the list. Not the last item, but the last visible item in the list. So in the notification item, what are we gonna do? Start position. I'm thinking to comment out this animated style and to kind of disable the animation that is related to the visibility of a list, because they will work based on the same properties like opacity, scale, translate, and it's going to be confusing for us like what we are animating, the last item or the list visibility. So let's comment it out and let's define it one more time. And now we're going to work on the animation for the last element in the list, and at the end we're going to merge them together based on some conditions. So animated style equal use animated style, and this is gonna be the return an object with some changes to our opacity, like at the moment is 1, but we're gonna work with that. So yeah, one more thing that I want to do is to disable the animation for the footer, because that will also impact a lot this last item animation. So let's try to simplify the use case as much as possible for everyone to understand, and then we will try to merge them together with different animations and see how they perform together. So let's go ahead in the notification where in the app.js. If I'm gonna simply comment out our footer like this, then yeah, like it's gonna be much easier for us to work with this. Okay, so now back to our notification item. Shall I bring it to the top? Let me bring it here. So the opacity we will also interpolate, but we need the value to interpolate it on. So what value will drive the animation for the last item? The last item will be animated whenever we scroll up and down. So the value that will drive that animation will be the scroll Y position. So let's go ahead in our list. Let's define a shared value for the scroll Y, use shared value. It's gonna start at 0. We're gonna update it every time we scroll. So the first thing we do is scroll Y dot value equal to the Y that we receive from the event. And this scroll Y we can send to every single notification item, scroll Y. Now, knowing this scroll Y, we're gonna have to interpolate it to get our desired value. So the scroll Y will have a very big range. So it can go, I don't know, like from 0 to, let's say from 0 to 100, not even 100, let's do more like 500. And the output values for our opacity, we need it from 0 to 1. Here I'm not explaining, let's just go with it and see scroll Y, and we need to scroll Y dot value. We just need to see something on the screen, and then based on that we're gonna start working. So as you can see, when the scroll Y is 0, our opacity is 0 and nothing is visible. And when we start scrolling, we slowly start seeing all of them at the same time. Similar to the problem that I explained before, in order for the items not to behave simultaneously, because at the moment they all behave as one single item, they all appear or they all disappear. So in order to detach them from each other, the same way as we did previously, with changing the distance that they have to travel, the same way we can adjust the specific ranges when the opacity should go out and should go on based on the index item. So this is item. Let me actually do it one more time, and I'm gonna do it a bit differently. That's gonna be my phone, and these are gonna be my items. I'm not gonna have a lot of items. I'm gonna have probably 3 items to explain it. All right, so this is item number 0, this is item number 1, number 2, number 3. We know the start position of each item, right? So this is 0, this is, if we look in our code, the start position is notification height, which is 80, and multiplied by the index. In our case, I will assume that the height of the item is 100 pixels. So I will say that this is 100, this is 200, and this is 300. So these are the start position of the items. Now, if you remember, our animations are driven by the scroll position. So at this moment, when the items are here, the scroll position, scroll equal 0. When we scroll down and we see the first item here on the screen, I mean the second item, here the scroll position equal to 100. And also the same like below and below. Now let's go back to scroll 0. Let's implement these start positions in our animations that will differentiate when the animation runs for every single individual item. So let's go ahead in our project, here, and the scroll Y, the opacity. For the start range, we're gonna use the start position of the item. So here, let's do 0 will be start position, and for the next one, we should do start position plus notification height. Basically, this is the next item. This is this item and this is the next item. And what that does for us is if I scroll, as you can see, the items on the bottom are slowly appearing when they are reached this position. What's that position? That position is actually the position of the first item. So when we are in the position of the first item, they are fully visible. But the problem is that we don't want to start their animation when it is in the first position. We want to offset it with the height of our container. So they shouldn't appear here on the screen, they should appear when we reach the bottom of the screen. So for that, we're gonna add the container height to both of these. Should we add or should we subtract? Container height minus container height. So now we offset the position when these elements start appearing. We offset it by the container height. So whenever they are at the bottom here, they are fully visible, as you can see. And this way, our scroll animation is already looking good. Actually, I don't know how we landed from the first time in this position, because in a lot of cases, my animations were running properly, but on the top. So they were going from the top to the bottom. But now, as we can see, they are actually the way we want them to be. I would like to take this start position and the end position, I would like to take them in 2 variables. So position 1 equal this one, and position 2 is equal to this one. So let's now work with position 1 and position 2. I did that because in the next step, we're gonna animate other properties also based on the same position. And when I talk about other properties I talk about, for example, let's work with the transform or with the, both of them will be in transform because we have to work with scale and we have to work with the translate. So for that, let's define the transform, which is an array of multiple transformations. And one of them is the translate y. So how much should we translate? Again, this should be dependent on the scroll position. So scroll y dot value. The input range is going to be the same, only the output range is different. So when the opacity is 1, the translation should definitely be 0, because when the item is fully visible, I want it to be in the position it is supposed to be. But when the item is invisible, I want it to be moved a bit. So with a notification height, Let's see. Okay, it doesn't look very good. Scroll Y, translate Y, scroll Y value. I think it's minus notification height. Oh, no, that's interesting. Oh, yeah. The interpolation, the way it works, it defines how to map two values, one value to another value. So for example, we have a graph, and here we have what do we have here? The scroll position. So the scroll position starts from 0 and it goes all the way to, like, I don't know, infinity, right? And if yellow is our scroll position, the scroll position can actually be negative as well, not only positive. But when we define the interpolation, we define two positions, position 1 and position 2, which are somewhere like, I don't know, let's say here, like, and here. Now we are trying to map these two positions to minus notification height, which represents the position 1. So minus notification height is gonna be here, and it represents our first position, and the second value is 0, which corresponds to the second clamp position. So this is going to be our output value. Here I said that this is start position, and this is the no, this is pose 1 and pose 2. Pose 1 and pose 2. When our scroll is in pose 1, the translation is minus notification height, minus 100, let's say. And when it's in position 2, the notification height is 0. But interpolation, how it works is, yes, we gave it basically only like this range. But because our scroll position is a continuous thing, like it can be from minus something to plus infinity, there are two options to adjust our mapped value. And one of these options is to clamp it. That basically means that outside of this range is going to be clamped, meaning it's going to be the same, like this, or we can extend it. Extending it means that we follow the same trajectory. And the problem with our items is that automatically the flat list doesn't clamp, but it extends. And as we can see, the items move all the way like there based on the scroll position. So they move quite a lot. Like in when the scroll position will be minus 10, then all the items will be moved to, I don't know, minus 100 or minus 1000. But we don't want to do that. We actually want to clamp the position of our translation to these values. So if it's lower, it's going to be still minus 100. If it's higher, it's going to still be 0. So this is called clamping. Right. So to specify how we want the interpolate to clamp or not, we can specify it as the next parameter, extrapolate.clamp, that we can import from here. We can say extrapolate.clamp. And now, as I said, like the minimum value will be minus 80, that's our notification height, and the maximum value will be 0. And this way, as you can see, the last item seems that it doesn't move, right? Because that's how we wanted it to be. If we want to make it still move but a bit slower, we can divide this notification height by 2, for example. And let's hope that my PC doesn't crash. Notification height divided by 2. This will make it move but a bit slower. So as you can see, the items still move, but they move a bit slow. The last item still moves but moves a bit slower. And I think this is actually much better than I had before, because I had it like this, and when it is like this, it seems that the last item doesn't move at all, and it only appears. So let's divide it by 2. Probably it will look a bit better. Divided by 2. Yes, like this. Okay, so as I said, beside the opacity and the translation, we should also work with scale. So the scale will be like also this kind of interpolation based on the scroll value, starting from position 1, position 2, and the scale should go from 1 to 0. Where is the 1 and where is 0? And probably not even 1 to 0, but 1 and 0.5. So I'm not going to think where to put which value. I'm just going to define it and see. And as I can see, it's not there. It should be 0.5 and here 1. Now, okay, now it looks better. And here you can play with the value of the scale. I think 5 is too much, so I'm gonna do 0.8, and this way it's gonna look much better. Yes, that's our animations. Perfect. I want another thing. I want to, for our notification list, where we have like some styles or where, I want to see if we are animating them at the right position. Because this notification list, let's give it style, background color, red, and I think we're not animating it right at the bottom. So for that reason, I don't even need the style because I know it's all the way till the bottom. So for that reason, we should think about moving it a bit. For example, notification item height. Oh, because we are, yeah, we think that we have the footer there. So if I'm gonna remove this -85 for the footer, the container height, yeah, now it should be better. Let me go back to this one. As I said, now the next step would be to group together the animation of the last item and the animation of all the items when we are trying to hide them. So if I uncomment this one here, animated style 2, let's do animated style 2. The way to go is, based on the list visibility value, we should decide what should happen. Because if list visibility is 1, that means that the list is visible and we need to simply animate the last item. However, if list visibility value is less than 1, that means that we are animating the whole list, not only the last item. So for that reason, I'm gonna work with the first one here. For example, opacity. Let me actually do it like this, const opacity. Let's simply do an if statement and return different. The list visibility value, if it's equal to 1, or let's do if it's more than equal to 1, because if it's a string, then this list visibility might actually get to a bit more than 1. So if list visibility is more or equal to 1, that means that the list is visible, so we're animating the last visible item. So for that, let's simply return this thing. Otherwise, after if ends, we can say else animate all items to hide them. So otherwise, we're gonna return this statement. Will that work? So now all of them are here. When we scroll, the last item is being animated. And when we get to the top and then when we close that list, they go away, and just like that, we move back. Perfect. On a real device, it's much more smoother. Like my actual MacBook is slow because, as you can see, like everything is slow. So we merged together the two animations for the last visible item and for the hiding of the items. Now let's put back our footer there and think about what do we have to do to work with it. So as you see, like the last visible items here is working properly, but if I swipe, it should move as the footer disappears. It should move to the bottom to take out the available space, because right now we have like this empty space there. At the moment, how we're doing is we are simply working with in the notification item with this initial height of our footer container. But what we are interested in is in the height at the current position, at the current time, I mean. Because the height of a container changes with slowly, gradually, that means that it's gonna be a shared value. So in the app.js, we already have this footer visibility. We already have this margin top, which is the interpolation. What we have to do is to send this interpolation to, as a margin top, we can send it to down to our notification list. So footer height, let's do it like this, equal to interpolate footer visibility value 0, 1. And let's not do minus, but plus, and actually it should be other way around. If we represent it as footer height, then when the footer is not visible, the footer visibility is 0, then the height is also 0, and when it is visible, the height is 85. So with this footer height, let's go in our notification list and let's receive it here like this, footer height. Now, footer height, I'm interested what is the interpolate giving us back, a shared value or a normal number. Returns the value after interpolation from within the output range. All right, that means that it's not gonna work properly because we need a shared value. We need a property that will not trigger JavaScript re-render. So for that, what we can do is to use instead of using a shared value, we should use a derived value because this value is derived from the app.js, use derived value. And we need that because our value is based on the footer height equal use derived value is this footer height depends on the footer visibility. So let me take this interpolation. So this footer height is going to be a function that will interpolate footer visibility from 001 to 85. Now let's give this footer height to the footer height here, and this way it's already a shared value. Now in the notification list, we receive this footer height, and what should we do? We should send it down to our notification item, footer height. And in the notification item, let's receive this footer height, and instead of hard coding this 85 here, let's do footer height dot value. Now it looks like this, and if I scroll up, it doesn't change at all. So let me refresh. Now it looks like this. If I scroll up, no, it doesn't change. Let me try in the application. I want to console log the, I don't know, console log footer height dot value. Container height. Oh, the container height should also be a derived value because it depends on the footer height value, which is a shared value. So without that, it doesn't update automatically. So we need use derived value, and that's going to be used derived value, and this is going to be the derived value. Now, where we access container height, we should do container height dot value, container height dot value, and come on, it disappears, and now the items move respectively. I'm getting some errors. Let me stop console logging. No default value, and it happens when I scroll down, when I release. Yes, no default value. In the notification item, probably the container height, I did it in multiple places. Yeah, container height, well, it should be container height dot value, and yeah, that's it. Now it should work, and it smoothly appears behind the footer. All right, so with that being said, our animations are done. So let me quickly commit animated FlatList. All right, guys. So let's have a quick demo if my computer will allow me. So we implemented a couple of things here in the FlatList to make it look good, and one of them is the animation of hiding the footer whenever we start scrolling. This is done in iOS in order to give more space for our list. So if I start scrolling, you will see that our footer disappears and the rest of the space is given to our elements here. And what I like about this animation is that it doesn't jump to having more space. It slowly, and very smoothly moves there together with the last element. So we can see it one more time, and here it is. Now, when we are back up, our footer slowly appears back on the screen. The next animation that we worked on is hiding the notification list whenever we scroll down. And this was a fun animation because we had to animate every single item in this flat list in order for them to move with different speeds, because the first item should move much faster than the last item in order to have this effect of stacking everything together, not simply moving all the items at the same time. So if you see there is this effect of all the items gathering in the middle bottom of the screen. After that animation was done, we went on animating the last item in the list. So as you can see, the last item really smoothly appears in the screen. We played there with opacity, with translation, and with the scale. So the last item like really seems that it doesn't go below the screen, but it goes behind like the previous items. So this is a really nice animation. And if you enjoyed this tutorial, make sure to smash the like button down below and subscribe to our channel not to miss our future tutorials. Now check out this tutorial here to learn how to build a beautiful 3D parallax effect, or this one here to learn how to manage gestures in React Native.